Hello, everyone. Before we'll start, we'll just give it a couple of minutes so people join us. Just wait a bit more. There's some people joining us. Just give it a minute or two, and then we can start with the introduction. I guess we can start and people can join as we start with first the introduction. Once again, hello everyone. Welcome to our webinar today. Today we are going to take you inside the migration we just completed. We were moving our entire Angular portfolio of NgModules onto standalone components using AI in a structured, controlled way. The important word in this sentence is structured. AI didn't do this on its own. We didn't just throw a cursor or Copilot license and hope. What we'll show you instead is our AI SDLC at work. That's the way we embed AI into every step on how we deliver software, from the first look on the documentation through let's get started. At AV, knowledge sharing is the part of how we work, and the migration you're about to hear wasn't just a side project for us. It was a structured initiative built on top of AI SDLC we use every day, with a written internal guide, branching strategy, and explicit non-rules. We treated it the way we treat every modernization for our clients: incremental, controlled, and AI supported all the way. Now I would like to hand over to my colleague, Milan Petrovic, who led the technical side and did the work hands-on. He wrote the migration guide and the one that we'll be sharing rules from today. So without any further ado, Milan.
Thanks, Larissa. Hello, everyone, and thank you for joining today. My name is Milan, and I'm software developer at AVS Solutions. Before we begin, I'd like to introduce my colleague Vladimir, who will be presenting with me today.
Hi all, my name is Vladimir Nešić and I'm a solution architect with a 20 plus years of experience. I'm working on cloud solutions and also on front-end solutions together with Milan.
Thanks, Vladimir. Today, I'd like to share our experience migrating our Angular portfolio to Standalone and how AI helped us make that migration faster, safer, and more consistent. Before we dive in, let's take a quick look at what we'll cover over the next 40 minutes. First, I'll explain why we decided to start this migration in the first place. I will share the challenges we faced, the strategy we used, and how AI helped us analyze applications and execute migration tasks while engineers remained responsible for validating the result. After that, I'll cover some lessons we learned, a few pitfalls we encountered, and guardrails that help us avoid bigger problems. And finally, we'll switch to a live demo and see the approach we used throughout the migration on a real Angular project. So let's start with the first question. Why migrate at all? We decided to migrate because we could clearly see where Angular was heading. Frameworks involved, and Angular is no exception. Over the last few releases, Standalone has become the recommended way of building Angular application. It's now the default architecture. The documentation is Standalone first, and most new Angular features are designed with Standalone approach in mind. And if you're still working with NgModules, you eventually start feeling that friction. A simple example is component generation. Every time we generated the new component directive or pipe, Angular wanted to create it as standalone by default. And we kept adding standalone files again and again. At some point, it becomes clear that your application is moving in a different direction than the framework itself. There were practical benefits as well. Dependencies become easier to understand. Lazy loading becomes simpler. Component boundaries become clearer. And onboarding new developers become easier because features are more self-contained. So for us, this wasn't about chasing the latest trend. It was about modernizing our application and aligning with the future direction of Angular. Deciding to migrate was actually the easy part. The real challenge was figuring out how to do it safely across the entire portfolio of applications. We weren't dealing with a single application. We were dealing with a portfolio of 10 applications, more than 100 modules, and a shared library containing common components, services, and business logic used across the entire portfolio. This shared library had continuous supporting applications that were still using NgModules, while also supporting applications moving to standalone. Backward compatibility was a requirement from the day one. Some of these applications had been evolving for years. Our largest application contained more than 30 modules, each with own dependencies and architectural decisions. New features, bug fixes, and releases didn't stop because of this migration. So the challenge wasn't migrating to standalone. The challenge was doing it safely across the entire portfolio while continuing normal delivery. Which brings us to the key question: how do you migrate the entire portfolio without stopping delivery? And that's where the migration strategy starts. Before changing anything, we use AI to analyze the portfolio. It helps us understand application structure, share library dependencies, and spot where the migration risk was highest. That visibility allowed us to build a strategy before we began the migration. And the strategy was simple. Start with the smallest application, then smallest module, learn from those migrations, standardize the patterns, and only then scale to larger and more complex systems. We also made a deliberate decision to keep changes small, one module, one pull request, one migration at a time. To support the migration, we relied on Angular Standalone Migration Toolkit. At the center was Angular Standalone Schematic, which automated much of the migration process. Together with import provider from, provide, API, and deprecated annotation, it allowed us to migrate incrementally while our shared library had backward compatibility. At this point, we had a strategy and we started migrating applications. After a few migrations, something interesting happened. The same patterns start appearing again and again. The same Bootstrap application changes, the same feature module changes, the same provider migration, test updates, and build and lint issues. And we realized we were learning something with every migration. So instead of keeping that knowledge in our heads, we started documenting it. The first playbook wasn't about migration at all. It was about analysis, understanding the application, finding what should be migrating, and deciding the migration order. We follow a simple approach. First, migrate the Bootstrap application, then start the smallest module and step by step move to larger and more complex one. Shell library was migrating along the way whenever application needed standalone support. Every shell library change had to remain backward compatible, allowing both standalone and NgModules application to continue working at the same time. That gave us confidence to adopt the standalone approach without worrying about breaking application that not yet been migrated. After that, we documented the migration process itself. How to migrate Bootstrap application, how to migrate feature module, and shell libraries. Each playbook contained migration steps, validation rules, common pitfalls, and the lessons learned from previous migrations. We also embedded the Angular migration toolkit into those playbooks. Over time, these playbooks evolved into AI skills. And once that happened, AI was no longer trying to figure out migration on its own. It was executing migration processes that had already been defined, tested, and improved through real migration work. That consistency became the foundation for scaling the migration across the entire portfolio. And at this point, we had migration playbooks. The next question was, how did we actually use them? Every migration started with analysis. AI analyzed the application and generated migration backlog. The backlog contained migration tasks and recommended migration sequence. Once we had the backlog, we simply selected the next migration task. Each migration scenario had its own skill. From there, the work entered the AI execution loop. AI executed this selected skill, apply Angular migration tooling, performed the migration steps, and continuously validated the results through build, test, and lint. Whenever an issue was found, AI attempted to resolve it and repeat the validation cycle. This continued until the migration reached a stable state. At that point, the engineer reviewed the results, not to verify every import or provider change, but to validate runtime behavior, architectural decision, and ensure the migration stay with the scope. If everything looks good, the code was ready for a pull request. In practice, workflow was surprisingly simple. Analyze project, generate backlog, select the next migration task, execute appropriate migration skills, validate, review, and repeat. The real value wasn't the workflow itself. The real value was that every migration followed the same workflow. That consistency allowed us to scale that few successful migration to entire portfolio, from the smallest application to the larger ones. And after dozens of migration, we started noticing the same mistakes appearing again and again. Some were made by AI, some were made by engineers, and those lessons became rules. The rules that every migration playbook and every migration review had to follow. The first rule was stay within the migration scope. This is especially important for AI. Left to check, AI tried to be helpful by fixing things outside the original scope. Unfortunately, that's how small migration become large refactoring projects. That's why every skill had strict boundaries, defining exactly what AI was allowed to change and what it had to leave untouched. The second rule was don't guess. If something requires architecture judgment or a specific provider pattern, AI stop and engineer review it. The third rule, backward compatibility is a feature. Without backward compatibility migration, an application could easily break another application. And finally, build, test, and lint are not enough. Green pipeline does not guarantee a working application. Runtime validation remain a mandatory parts of every migration. End-to-end tests. These 4 rules prevented us from repeating the same mistakes and help us scale the migration safely across entire our portfolio. Now, let's switch to live demo and see this loop in action on a real project.
Now, while Milan is preparing for the demo, I'd like to let you know that we've opened our Q&A session and we'll have questions after the demo, so feel free to enter your questions as he presents.
Okay, here is one Angular project that was still fully based on NgModules. I want to run the AI agent and the complete migration loop for every step because that would take too much time. I will show commits that I made. And first commit was add skills for standalone migration. And each skill is designed for a specific migration scenario. If you check here, we have for Bootstrap application, for feature module migration, final cleanup, and as well, every migration starts with standalone migration analysis. When we put this skill into AI agent, the agent scans the repository, analyzes the current state, and generates migration summary. And I will show the screenshot of that summary. It is right here. What you are seeing here is the migration plan. Before changing any code, we already know the migration order, dependencies, risks, and which skill is responsible for each task. Current state of my application is Angular version 21, 5 modules, 9 components, none of them are standalone. Bootstrap application uses platform browser dynamic, the old way of bootstrapping application. As well, this skill recognizes that my ESLint rule is off for prefer standalone. In the table, we see the order of backlog of task actually. Each task is assigned, appropriate skill. And if you like to automate this process, you can use MCP to automatically generate tasks in your management system as well. On the right column, we can see efforts, large, medium, small, and there is as well dependencies column. It is interesting for row 6 task module target. We see that it depends of 4 and 5. It means that task module and share module for task module, share module and filter module need to be migrated before because it depends on them. And this prevents migration from happening in the wrong order and reduces risk. As we see, the first task is app module using standalone Bootstrap migration. If we copy paste this in our agent, we will get a result like this, and output of this migration will be code review, will be change files related to app config. Tasks in to-do list that are done. Create app component yes, update main yes, make app component standalone, make version component standalone, remove app module TS. At the end, execute loop for validating process, for tests and build. Now, let's together check the code this pull request. And the first thing we notice is the pull request is small and easy to review. If I check, for example, main TS, it is standard replacement from platform browser dynamic to bootstrap application. And as well, root component is migrated to standalone true, as well with appropriate imports, notification component, root outlet, version component, and version components is automated converted to standalone true as well without dependencies. And to be honest, these changes, Angular standalone schematic can handle very well as well, you know. But the real power and the real value of AI migration is here. If you check this file, app module TS is migrated to app config TS, and using migration rules and knowledge of our share library, it replaces modules with correct provider-based APIs. Notification module become provide notification. It even identifies the correct providers by analyzing external libraries. Effect module becomes provide effect. Store dev tools module become provide store dev tools. This is work that would be normally require developers to manually inspect modules, read documentation for different libraries and provider registrations. As we see here, we have many pull requests, and I won't go through all of them. What's important to understand, the process is always the same. Pick up task, run the assign skill, let's agent complete the migration and validation loop, and it will verify a test loop at the end. Engineer can review that changes, create pull request, and repeat until until migrate the whole project. Slavice.
Thank you. Okay, now we'll move on to Q&A session.
Okay. Yeah, there are a couple of questions that we received. The first one is, what AI tool did you use?
We are using Cursor and Claude in AWS. We didn't try Codex yet, and we know all of these tools are powerful. And it tells us one thing, the bigger value comes from the good defined workflows, playbooks, skills, and guardrails. I think the real value is there.
Okay, and just I'm curious, what is your preference? Like, if you would need to choose between Cursor and Claude Code, what is your favorite tool?
I'm not sure to say. Yeah, Claude for sure. Claude for sure.
Claude, okay. Fine. Then there was a question from Milovan. Why didn't you migrate everything at once? So what is the reason to go step by step and try to do this in not all at once, let's say?
Yeah, it is a fair question. For projects that contain a few modules, maybe it can be a valid approach. But for us, the risk was too high. We wanted to learn from smaller migration, make some lessons from them, and before moving to larger and more complex projects, as I said, we have a lot of big projects.
Okay. Then a question from Mirko. Did AI actually save time? So what is your opinion? Is it worth it to invest in this AI, I would say, tooling that you made around this? So did that save your time at the end?
I didn't put that in presentation, maybe because I'm developer, I'm not sure, but yes, it saved time for sure, but not immediately. In the beginning, we invest a lot of time improving the process, defining migration playbooks, and teaching AI our migration rules. It is important that this migration contain a lot of repetitive work, and that's exactly where AI perform best and developer motivation go down. In some cases, we were able to migrate 5 or 6 modules in a single day with pull request. 90% of migration was executed by AI. And comparing to manual approach, maybe say, productivity improvements was 2 or 3 times, but I already presented the replacing of app module TS. It is 10x for sure. It requires a lot of energy for replacement each of that provider.
Okay. Then there is a question that is very interesting also for me. So Dayan asked how much of that runtime validation was automated via end-to-end testing tools like Playwright or Cypress versus manual verification. And did you use AI agent to help you to generate those cases?
For sure, manual testing is really important in runtime. After each module migration, it is important to check that. And at the end, project is important to run end-to-end tests to be clear that everything is green and everything works as expected. I'm not sure did I answer correctly, but.
Okay. Yeah, I think it is fair answer. I think that end-to-end tests really help to make more. I think end-to-end tests are like a safety net. So it really helps you to progress and that you don't need to manually check all the steps. So I think that end-to-end testing can be very beneficial in cases like this because you can run end-to-end tests and be sure that that there is no regression. So from that point, I think it is important to have them and to execute them in situations like this. I know that there will be cases that are very specific that something is not working in a runtime and it is not recognized by end-to-end tests. But again, I think that majority of the testing can be done through end-to-end testing tools and the coverage that comes from that part. Then there is one more question about tests. This time, Stefan is asking, how did you what is the migration impact on the test coverage and the code quality? So can you elaborate or give more details about impact on a test coverage and also on a code quality? Do you think that there was increase in a code quality at the end?
Maybe sure. I think yes, but related to test coverage, it stays the same. Important thing for unit tests. There is boundaries that AI should not touch logic of the tests, not change the previous written tests. It is more important as well as the logic of the code. If something doesn't work, it is important to focus on probably on imports, probably on that issues, but it is important to don't touch anything, and at the end the result is pretty much the same code coverage.
Okay. Nicola is asking about AI and did AI ever introduce problems? So did you had that hallucination parts and moments when AI was I would say not doing what it's supposed to do? So any comments on that?
Yes, for sure. We had a lot of problems, especially at the beginning. That's why defining clean boundaries was so important, because AI can sometimes be unpredictable and confidently make the wrong decision. And at the end, responsibility is on engineer to review that code, to check everything, and AI only executes these rules that we gave them.
Okay. And then Boris is asking, how did you manage branching and releases while this migration was happening? Because it took some time to migrate everything. So I think it is fair question because there is always a struggle how to deal with the features that are long with a long development timeline. So what is your
For
experience
sure,
on that part?
I haven't put that in presentation. It is part of the process, how you manage your branches and releases as well. There is actually three approaches. One is a little bit defensive one. Keep everything on feature branches, wait to complete all the project, and then start end-to-end testers QA can test that, and after that merge to develop. This is one approach. The offensive way is to merge migration PRs directly into develop one by one. It is a good approach because your developer can get familiar with standalone approach in early phases, but pressure is on QA to test all time everything. We decided to use a hybrid approach. Some save small migration when directly into develop, while larger changes stay on feature branches until they were ready. And that is good approach as well to estimate the risk.
Okay. Okay. There are no more questions. I have one question for you. So if you would start this migration from the beginning, is there anything that you would done differently? So is there something that you realized down the road that there was something maybe that you could do differently or in a different way, or anything that is a kind of a lesson learned?
Yes, for sure. From beginning, start with process automation. Write everything in playbooks, documentation. Try to notice every error, every exception, every pattern and decision. It can help in the future for code consistency and consistent changes in the future. For me, that's the point that if I'm doing everything again, to start from day one to think about automation of the process.
Okay. Those are all the questions. We don't have anything else in a QA section. So once again, if there is any question from anyone, please post. If not, I think that we are very close to end.
Okay, thank you. If there are any other questions that you may have, feel free to email us and we'll do our best to answer. Once again, thank you for joining us. The recording and the presentation slides will be in your inbox within next 48 hours. If anything resonated, whether it is the standalone migration itself we did or this bigger picture on how to wire AI into your delivery process safely, we'd love to talk. Our AI SDLC isn't just for migrations, it is how we deliver every project. And if you are wondering if something like this or similar could work for your team, There's a link on this last slide where you can book a 30-minute discovery call with no commitments. We'll also be posting some follow-up material on LinkedIn over the next few weeks. Thank you again, and we hope to see you at some of our next webinars.
Thank you.
Thank
Thanks
you,
a lot.
everyone. Bye.
Thank
you.
Thank you. Bye.
Have a nice
Bye.
day. Bye bye.
Bye. Thank you. Goodbye.
Bye.